continuing with application of calculus in commerce and economics. This is the next question that we will work out today. Okay. The question says, a profit-making company wants to launch a new product. Okay. It wants to launch a new product. It observes that the fixed cost of the product is rupees 35,000 and variable cost per unit is rupees 500. The revenue function for the sale of X units is given by 5000x minus 100x squared. So revenue function is already given to you. Find number 1 the profit function, and number 2 the break-even values. So part 3 values of X which result in loss. So this is what they have asked you to find. 3 subparts to the question. Okay, to find the profit function, we need to know the cost function and the revenue function, isn't it? Profit function is what? Profit function is Rx minus Cx. So let's frame the Cx first because Rx is already given. Rx, the revenue function, is given as 5000x minus 100x squared. This is your revenue function. What is the cost function therefore? Cost function Cx, it is supposed to be the variable cost plus the fixed cost, isn't it? And therefore that is equal to, what is the variable cost? Here they are saying variable cost per unit is rupees 500. For 1 unit it is 500. For X units it is 500x. So you will mention where X is number of units manufactured and sold. Okay. So 500x is your variable cost. Fixed cost is how much? It's given already. Fixed cost of the product is 35,000. So plus 35,000 over here. So this is your cost function. Since they are asking you to frame the profit function, so let us frame the profit function first. Okay, otherwise to find the break-even values we could have done Rx is equal to Cx directly, isn't it? So let us frame the profit function. Subpart 1, the profit function. Profit function, according to definition, it is Rx minus Cx, and therefore it is 5000x, this is your Rx, minus 100x squared minus 500x plus 35,000. Okay, so therefore it is actually 5000x minus 100x squared minus 500x minus 35,000. So it is coming to how much? 5000x minus 500x we will know because these are the two x terms. That gives us 4500x. The rest as it is minus 100x squared minus 35,000. So this is your profit function. You can write it as Px, and this is your first answer. Next, subpart 2. Break-even values. Since we have found out Px, let us use Px is equal to 0, isn't it? So for break-even point, condition is Px should be equal to 0. Px equal to 0 means it is 4500x minus 100x squared minus 35,000 is equal to 0, equating this to 0. Okay. So notice it can be reduced further. In fact, you can rearrange and write as a quadratic. Actually, it is minus 100x squared plus 4500x minus 35,000. So that throughout you can divide by 100 and a minus 100 in fact. So that this becomes x squared, this becomes 45x, and this becomes simply 350. What did I do? I divided throughout by minus 100. Or you can say I took minus 100 common and it is a constant. So the rest of the equation, quadratic, is what I have taken for simplification. So what will I do now? Obviously middle term factorization. What will be the factors? Middle term, I think you know how to do. You are in class 11 and 12 now, so I don't have to explain that. Obviously it will be 35 and 10. So x square minus 35x minus 10x plus 350 is equal to 0. So you are getting x common, x minus 35 minus 10 common, x minus 35 is 0. So it's x minus 35 into x minus 10, which is 0. So the values of x are 35 or 10. So conclusion, what will you write? Break-even values are either are either 35 units or 10 units. This is your answer for the second subpart. Okay. Now the third subpart. What does it say? Find the values of x which result in loss. Loss means what? Obviously there is no profit. In fact, profit function value, whatever value of x you get for loss, it will give you a negative value. Profit function positive means there is surely a profit involved. Equal to 0 means break-even values you are getting, which that means it is the values of x for which there is no loss even if there is no profit. Okay, but then when the situation is such that we don't want any loss at all, then the loss is happening. The question says will result in loss. So when the loss is happening, so obviously it has to be less than 0, isn't it? Because at 0 there's a stable condition. At greater than 0 is a good condition. It is a sign that you are earning a profit, because profit function positive means that is you're getting a positive value. Whereas for loss means profit function value will be negative for that particular value of x for which it is loss. So for loss, what will you solve? That is, for loss, the situation is that profit function is value for that particular value of x will be negative. Okay. So, and that means we have to solve that equation. What did we have? We had we got it as minus 100x squared plus 4500x minus 35000. This is what we had originally. So this we will write it as, when we are taking minus 100 common and removing it, then it is going to become x squared minus 45x plus 350. The sign will change, greater than 0, isn't it? You're dividing by 100 and you're taking minus common. Now that is, I think I'll write that. Minus you took out. This is the situation actually. Leaving out 100. 100 is common throughout. So 100 is as it is a positive constant. So therefore it becomes this. Greater than 0. Okay, this is a concept which you have learnt in lower classes. I don't need to explain. I think factorization we have already done, so I won't repeat that. Straight away you will write this is x minus 10 into x minus 35. Inequation sign will remain the same. I suppose you remember the method of intervals. This is where you have to apply that. X is equal to 10, x is equal to 35. Here it's supposed to be positive, negative, positive. This product is positive here, this product is negative here, this product is positive again over here. So if I take values of x in these regions, this is the sign of the product. What do I want? I want that range where the product is positive. Where is it positive? The product is positive over here and here. So therefore you will write, this implies x has to be less than 10 or x has to be more than 35. That is what I have, isn't it? This is x greater than 35. This is x less than 10. So you will write the conclusion as, the company will suffer loss if either x less than 10. Okay, the company will suffer loss if either x is less than 10 or if x is greater than 35. That is, if less than 10 units or more than 35 units are manufactured and sold. So if less than 10 units or more than 35 units are manufactured and sold, then the company is likely to suffer a loss. Otherwise, that means if it is between this and this, between 10 and 35, then it won't be any loss. That is what it means indirectly. Okay. So this is the solution of this question. We move on to the next question now. This is the next question. The question says that a company sells its product at the rate of rupees 6 per unit. Okay, it sells its product at the rate of rupees 6 per unit. The variable cost is estimated at to run 25% of the total revenue received. That means variable cost will be 25% of the revenue that is obtained. Revenue, how will it be obtained? Obviously, they are saying that each product is 6 rupees. So if I assume that there are X products, then the revenue will be 6x, isn't it? So 25% of that 6x will give me the variable cost, because 25% of total revenue means that. Fixed cost is given as 4500. Okay, and from there you have to find out the break-even values and number of units that the company must sell to recover its fixed cost. So let us begin with assuming that let X be the number of units manufactured and sold by the company. Okay, so then from the first line itself, we are getting the revenue, which is the earning. I hope you can see. Yes, earning, which is your revenue, is therefore 6x, because each is rupees 6. In other words, Rx is your 6x. I'll write that beside it. That is, Rx is your 6x. Now I need the cost function. Okay, what is the total cost function? Total cost function. This is equal to Vx plus F as such. What is Vx? Variable cost. There they are saying variable cost to be 25% of total revenue. That means here it is going to be 25% of the revenue plus fixed cost is how much? 4500. So I put it over there, 4500. Fixed cost does not depend on number of units, it is fixed. So this is giving me this goes by 4, this is 3, this is 2, so it's 3x by 2 plus 4500, and this is your cost function Cx. Okay, so revenue is this, cost is this. They're asking you to find break-even point. So what will be the break-even points of part 1? Since Rx and Cx are known, so break-even point will be given by solving the equation Rx is equal to Cx. In other words, 6x is equal to 3x by 2 plus 4500. So 6x minus 3x by 2, that gives you how much? 6x minus 3x by 2 will give you 4500. I think you'll be able to solve this. That is 9x by 2 gives you 4500. So x is equal to, I think I'll write that, 9x by 2 gives you 4500. So x is equal to 4500 into 2 by 9. 9 5s are 45. So here it's going to become 500. So that is going to become 500 into 2, that means it's 1000. Okay, so therefore what will be your answer? Therefore 1000 units have to be manufactured and sold. 1000 units have to be manufactured and sold for no loss, even if there is no profit. Even if there is no profit. That means it will recover its cost. That's all. Next, the second subpart. Second subpart says number of units the company must sell to recover its fixed cost. That means to recover its fixed cost means what? By selling those units, at least the fixed cost should get back. The company should get back. Okay. So that means I will write by question. The earning that the company makes should be same as the fixed cost. Earning or revenue, it's the same thing. Earning or revenue should be same as the fixed cost. That means what is the revenue? We have obtained it as 6x. So this means that 6x has to be 4500. So x is how much? Simply x is 4500 by 6, which means x is 750 units. So this is the number of units that have to be manufactured so that the company can recover its fixed cost. Okay, so this is how we work out this problem. We move on to the next question now. This is the next question. A company sells X tins of chocolate powder each day at rupees 20 per tin. Okay, a company sells X tins of chocolate powder each day at rupees 20 per tin. The cost of manufacturing these tins is rupees 15 per tin plus a fixed daily overhead cost of rupees 900. Okay, so the cost of manufacturing these tins is rupees 15 per tin. That means this part is your variable cost. Each tin is rupees 15, so X tins will be 15x. Plus daily overhead cost. What is overhead cost? The fixed cost. Okay, fixed cost is rupees 900. Question is asking you to determine the profit if 1000 tins are made and sold per day. That means if x is equal to 1000, here number of units are mentioned. If x is equal to 1000, since 1000 tins are made, what will be the value of the profit? That is what you have been asked to find. The second part says, how do you interpret the situation? This is the second part. How do you interpret the situation if the company manufactures and sells 200 tins per day? That means instead of 1000 tins per day, how will the situation change? Whether it will change at all. If 200 tins are sold, that means whether there will be profit or loss or what, that you have been asked to check and see. So the first part is what? It is given that SP of each tin is given. Selling price of each tin is rupees 20. So therefore from here I get the revenue function. Revenue function for x units, that is Rx is equal to simply 20x. So this is your revenue function. Next they are saying cost function. Now let us find out what is the cost function. Cost function Cx is equal to, this is your 15 per tin, so it's 15x as the variable cost, and fixed cost is 900, so this is your 15x plus 900. This is your cost function. Determine the profit. So let us find out what is the profit function. Profit function Px. It is supposed to be Rx minus Cx according to the formula. So this is 20x minus of, this whole thing becomes minus 15x minus 900. So that means it's becoming 5x minus, I think I'll keep this in bracket, and therefore it's becoming this 5x minus 900. Okay, so this is your profit function, and this is what we need in the remaining part of the sum. So let us highlight it. Now they are saying 100 units of tin is made and sold, so that means I will substitute. When not 100, sorry, 1000. When x is equal to 1000 units. How much is the profit? That means if I put x as 1000, whatever value I get, that will give me the required profit. 5 into 1000 gives you how much? 5000 minus 900. So can I write that side? Yes, it is rupees 4100. So this is your first answer. Determine the profit when 1000 units of tin are being made and sold. Now let us see what will happen when 200 units are sold. So when x is equal to 200 units, what is the value of this profit function? Let us see. So this is 5 into 200 minus 900. So that gives us how much? 1000 minus 900. So it is simply rupees 100. So how will you interpret the situation? You will say when 200 tins are produced and sold per day, the company's profit is only rupees 100. Okay. So when 200 tins are sold per day, then profit is 2 less of rupees 100 only. This way you can interpret the situation. Okay, so that was this question. It's a simple one. We move on to the next one now. That is, this is the next question. I'm reading it out. The average cost AC for a commodity is given by AC is equal to x plus 5 plus 36 by x. Okay, average cost is given by AC is equal to x plus 5 plus 36 by x in terms of output x. Okay, find, this is in terms of output, I hope you can read. Find subpart 1 total cost, subpart 2 marginal cost, subpart 3 the output. Output means number of units you are manufacturing and selling. That means you have to find the value of x. The output for which the average cost increases. Average cost is a function, and a function increases under what is the situation under which a function increases, or rather what is the mathematical relation that gives us the situation for which a function is increasing. I hope you remember that. We'll apply that over here. Okay, now we begin with, we know average cost is what? Yes, average cost is given by total cost by number of units. This is known to us by definition, isn't it? By definition of average cost. So therefore CX, average cost, I'll put the value, x plus 5 plus 36 by x is equal to Cx by x, because this is what is given over here. You've been asked to find the total cost. That means basically you've been asked to find the cost function. So therefore cross multiplying x into x plus 5 plus 36 by x gives you the total cost. In other words, the cost function Cx is equal to x square plus 5x plus 36. Just multiplying throughout. Okay, so this is your cost function. Let's highlight it as the answer. So basically from average cost, how will you get Cx? If you have noted, Cx is equal to AC to be multiplied with x, isn't it? Because Cx by x is AC, so Cx is AC into x, cross multiplication. Anyway, so next comes subpart 2. This is your subpart 1. Subpart 2 is marginal cost. Marginal cost, how do we get it? It is obtained from dc dx, ddx of c. Okay, So therefore it is d dx of the cost function x square plus 5x plus 36. d dx of x square is your 2x, d dx of 5x is your 5, and d dx of 36 is 0. So this is your marginal cost. You can write it separately. MC is 2x plus 5. This is your answer. The third subpart, the value of x for which average cost increases. Here we have to recall something. I'll write it in case you have forgotten. Recall. Okay, what will you recall? That any function fx is an increasing function if df dx is greater than 0. Otherwise it is if df dx is less than 0, then it is a decreasing function. So any function fx is an increasing function if df dx is, if its derivative is greater than 0. So here we will find out, what do we have to find? I will write that. To find, can you see? Yes. I will find the value of x for which d dx of AC is greater than 0, because they are saying average cost increases. Okay, d dx of average cost is greater than 0. So let's solve this. D dx of AC greater than 0. What do I get? So this implies that d dx of, what is AC? Let's write it, x plus 5 plus 36 by x has to be greater than 0. This is our desire according to the question. So it gives me d dx of x is 1, this is 0, and this is going to become d dx of 36 is constant. d dx of 1 by x is minus 1 by x squared. So this is what I have. Basically x square minus 36 greater than 0. How will I solve it? Use method of intervals. That is, in other words, I have, it can be factorized as x plus 6 into x minus 6, which is greater than 0. So according to method of intervals, I will rub this lower end. According to method of intervals, what do I have? Here is, suppose, x value minus 6, here is x value 6, plus minus plus, loop t loop t loop. Okay, that means here the product is positive, here the product is negative, here the product is positive. What is our desire? The region where x is, where the product is positive. So these are the regions where x product is positive. So you will write the solution as, this implies x is less than minus 6 or x is greater than 4, out of which this is not possible. Why? Because number of units cannot be negative. I'll write that, not possible as number of units. So what is your answer? So conclusion will be average cost increases if output x is greater than 6 units. You will write that. Therefore, average cost increases, average cost increases if output is more than 6 units. This will be your final conclusion. Average cost increases if output is more than 6 units. Okay, so this was the solution to this problem. We move on to the next question now. This is the next question. Cost function is, I've written it in brief, okay. Cost function is given as x cubed by 3 minus x square plus 5x plus 3. Find the output. Output means number of units x, for which the marginal cost is minimum. This is the first subpart. And the second subpart is output for which the average variable cost is a minimum. Okay. So what will we do? First of all, we need average cost and average variable cost. So for the first subpart, we are finding out the marginal cost that is needed over there. Marginal cost, I'll write in brief, MC. It is supposed to be dc dx, that is, it is supposed to be ddx of x cubed by 3 minus x squared plus 5x plus 3. So that means MC is equal to, this is becoming 3x squared by 3 minus 2x plus 5. In other words, MC is equal to x squared minus 2x plus 5. This is your MC. Okay. Now what have we to do? What is our aim? Our aim is to find x for which MC is minimum. In fact, minimum means minima. That means we have to apply the principle of maxima and minima. Okay. So that means what do we have to do? If you remember, principle of maxima minima, we have to equate the first derivative to 0 and we have to make sure that the second derivative is positive for the value of x that we get. Okay, so instead of, I'm writing m is equal to x squared minus 2x plus 5, that is your MC. So the first derivative I'm checking now, dm dx is 2x minus 2. d2m dx2 is simply 2, which is always positive. So therefore, do we have a maxima? Do we have a minima? It doesn't depend on x. Whatever be the value of x, second derivative is always positive. This implies m is a minima. And for what value of x is it a minima? For that we have to solve. For minima, dm dx is supposed to be equal to 0. This is what we are supposed to solve. This means, where is dm dx? This is your dm dx. So it's 2x minus 2, which is supposed to be equal to 0. So value of x is 1. So what will be your conclusion? Therefore, MC is minimum for 1 unit of output. This will be your conclusive answer for the first one. Okay. Now for the second one, what do we need? Average variable cost. Be very careful. It is not average cost. There's a term variable in between and it is average variable cost. That means average variable cost, if you remember, it is total variable cost by number of units, Vx by x, isn't it? So let us write down what is the variable cost. From there we will get the average variable cost. The cost function that is given is this. Cx is equal to x cubed by 3 minus of x squared plus 5x plus 3. Okay. From this, we know Cx is Vx plus f. So this is actually a fixed cost. And this part involving the variable x is your variable cost. Okay. So therefore, we'll write down what is the variable cost. Variable cost, VC, is this part, x cubed by 3 minus x squared plus 5x, so that the average variable cost that we need is actually VC by x, the variable cost by x. So it's x cubed by 3 minus x squared plus 5x, the whole divided by x, that means it's into 1 by x. So term by term we will multiply, or this is going to become x squared by 3. This into this is going to make it x. This into this is going to reduce to 5. So this is your ABC, average variable cost. What is our target? Our target is to find the output x for which the ABC is minimum. So again we have to use the principle of maxima and minima. Okay, such a big word we will not write, we will just write V. Okay, V is equal to x squared by 3 minus x plus 5. So the first derivative we will find out, dv dx, it is 2x, 3 remains as it is, this is 1. And what is d2v dx2? d2v dx2 is just derivative of this, because derivative of this is 0, so it's 2 by 3, which is always positive. Therefore, ABC is minimum. And what is the value of x for minima? For minima, the condition is that the derivative should be equal to 0, the first derivative. In other words, 2x by 3 minus 1 should be equal to 0. 2x by 3 minus 1 is equal to 0. From here you get 2x by 3 is equal to 1. So what is your x? X is equal to 3 by 2. So what will be your conclusion? You will write, therefore, average variable cost is minimum for 3 by 2 units. 3 by 2 units, number of units cannot be fractional, you will say that, but then minimum has to be this. Okay, so it can be 3 by 2 units of what did I write? Average variable cost is minimum for 3 by 2 units of output. This will be your answer for the second part. If it had been average cost, then it would be Cx by x, the whole thing by x. 3 would be included over here, right? And there would be one extra term, 3 by x it would be, and then the derivative. Okay, so this is how we calculate and find out the desired values that they are asking in the question.